Today we're going to take a look at section 3.1, Statements and Quantifiers. And the first thing we need to know is what we mean by the word statement. So a statement is a declarative sentence that's either true or false. Either true or false. So an example of a statement would be this. I ate cereal for breakfast. It is either true or it's false. Not every sentence that we say is a statement. So we're going to do a couple of examples of deciding whether things are statements or not, and then we'll talk about other items that maybe would fall into the not a statement category. So we're going to decide, yield to oncoming traffic. Is that a statement? No. It's a command. That is what we actually call it. It's a command. So this one's not a statement. Why does it fail to be a statement? Because we can't say it's true or false. It doesn't make sense, right? So this one's not a statement because it fails that true-false argument. 1 gallon of milk weighs more than 4 pounds. Yes, this one's a statement. It's either true or it's false. You may or may not know which one it is, but it is one or the other. Can you think of another type of sentence that would not be a statement? Commands. What was it? Questions. So somebody says something like, what did you eat for breakfast? That's neither true nor false either, right? So that one would be another example of something that's not a statement. All right. We have compound statements. So compound statements are simply joining two statements together. We join them with words called connectives. So some connectives that you're familiar with are and, or, not, but, if then. And there's some overlap in that list where a couple of them actually mean like the same thing. For example, the connective and the state connective but actually mean the same thing. English-wise, they have a little bit of a connotation there that's different, but they both mean and. So for example, if I said, I got up this morning, but I didn't eat breakfast, right? Those are two statements, right? I got up this morning, I did not eat breakfast. And if I put the word but in between it, it has a certain English connotation that we mean language-wise. But if I put the word and between them, it would mean the same thing. Those two statements are being either true or false, whatever they are. I got up this morning and I did not eat breakfast. I got up this morning, but I did not eat breakfast. They're the same thing. So these aren't necessarily unique statement connectives. They're just some that we see. The three that we're going to focus on the most are actually, hang on, let me get this out of here, my highlighting, are actually the and, the or, and the if then. Those are the three that we're going to see the most in the work that we do. Okay? So we're going to decide on the next couple examples if they're compound statements. They're actually telling us that they're statements. They said decide whether each statement is compound. The first one says, if Tom is a politician, then Jack is a crook. Is it a compound statement? Yes. There are two statements inside of there. What are the two statements?
Tom is a politician, Jack is a crook.
Right. These are the two individual statements that are inside of my compound statement. Since I have two or more, they're connected with the if-then. Notice how if-then spread things apart like that. Whereas when I gave you my example a minute ago with the words and but, it's just a single word in between them. That's okay. If-thens are a little different like that. But this one's compound with the connective if-then. How about tomorrow is Wednesday? No, that one's not compound. It is a statement, and it happens to be a statement that's true, like for us right now, right? Somebody's going to watch this 2 days from now. It's not going to be true anymore, but it's true right now for us, but it's not compound. Okay, now I mentioned the word not above, right? The word not can be a connective, but we also see this sort of an idea of something being not or no, and the opposite of something showing up in something called a negation. So a negation is the logical opposite of a statement. So I did a statement earlier that said, I ate cereal for breakfast. This statement is pretty straightforward on how we would create the negation. What would be the negation or the logical opposite of the statement, I ate cereal for breakfast? I did not eat cereal for breakfast. Yeah, absolutely. So we see that word not showing up. Notice that word not showing up in there did not create a compound statement, right? I still have one statement. So this is the logical opposite or the negation of the statement, I ate cereal for breakfast. But it's not always that easy. There are certain words that if they show up in there that make things a whole lot more difficult. And it comes from something called quantifiers. Quantifiers are words like all, each, every, no, none. That category of quantifiers are called universal. They apply to everything, right? If I say all my students, and then I put something after that, are boys, then it means not a single one of you can be girls and that make that work, right? Not a single one. So those are universal quantifiers. The other category are called existential quantifiers. These are words like some, there exists, for at least one. So it's just an existence statement. So again, if I used the statement before where I said all of my students are boys, all that it takes to make that statement false is one young lady to show up, right? That's all it would take. That's the existence part. There exists at least one that's not male, okay? And this is your word of caution. Negations are much more tricky when you have quantifiers involved. You need to be very careful when quantifiers are present. So we need to talk about what we do when we have quantifiers, because my example above didn't have one. It just said, I ate cereal for breakfast. It doesn't say, I always eat cereal for breakfast, right? It doesn't say, I only ate cereal for breakfast. That would be a universal kind of statement, right? It doesn't say that. So here's an example of one that has a quantifier. What is the quantifier, not the type, just what is the quantifier present here? Some. Okay? So the word some is the quantifier. What type of a quantifier is it? It's existential. Good. Okay, so it's important to notice because here's the deal. If you're trying to negate a statement and it has a quantifier, you have to change the category of the quantifier. So if it starts at existential, you're changing it to a universal quantifier. Everybody with me so far? So you first need to identify what type of quantifier you have. This one is existential. So the word some is going to change into either a positive kind of a universal quantifier, so something like all or every, that's a positive one, or a negative one, which would be like none or no. So I'm going to put no because the semantics with the English will work a little bit better. You have two choices. Now, when you do this inside of my math lab, these are going to come as a drop-down box, like a multiple choice kind of thing. So the reason I'm showing you both choices is not because either one's better than the other, but because they could put either one in as the correct answer. They won't put both of them. But you need to be able to pick which one they're talking about is correct, okay? These are both two ways of doing it. One's usually a little bit more natural with our English structure. It feels a little bit more normal. All right, so if we say some books are longer than this book, and we change it to all. If I don't change anything else in this statement, I just leave it all the same, and I just change the word all, and I say all books are longer than this book. Did that negate it? Did it make it the opposite of what was being said? No, it made it a stronger statement, didn't it? It didn't make it the opposite. So I have to change something else besides just switching some to all. What else would I have to change in order for this to be opposite of what I've got before?
A little bit shorter.
Very good idea. We want to be really careful. Shorter or
Shorter.
no? What's another possibility? Longer, shorter? Kyle? The same length. So it could be an equal length. You guys with me? We kind of think of these extremes, but sometimes there's that middle ground, right, where it's actually equal to in this case. So the way we get around that, instead of having to say shorter or equal to, because we could do that. I mean, we could do that. Say all books are shorter than or equal to this book. It's kind of wordy. So here's what we do instead. We say all books. Hang on, let me spare a little more space. Are not longer than this book. If you're reading that and you're like, Dr. Hans, that sounds kind of awkward, I'd agree with you. Of the two correct statements, this is the one that feels and sounds awkward with our English. But it is correct. I've changed the quantifier type, right? And I negated the pieces of the statement. Now let's look at the other one. If I have the word no, think about what will happen if I leave the rest of it the same. So have the word no. No books are longer than this book. Does that create the opposite statement? It does. So I don't have to change anything else on this one for this to actually be just like it needs to be. So the word no, right? I changed some to no. I did change something. I changed some to no. And then simply filling in what was there will work for the rest of it. No books are longer than this book. Okay, I want to do one more example. I thought I had one more in here and I don't. So I'm going to just flip to the very end of my screens. So I'm going to bypass all my slides. I'll come back to this when we'll finish up. But I want to do one more. Dark backdrop. That'll work. Okay. I want to do one that actually starts out with a universal quantifier instead of an existential quantifier to show you how you change that. So let's do this one. This is a fun one I sometimes do. We're going to do all dogs go to heaven. Okay, what is my quantifier? All. Okay. The quantifier is all. What type of quantifier is it?
Universal.
It is universal. So you cannot change all to none. Why not?
Because you'll keep it universal.
Because none is another universal quantifier, okay? So I have to change this word all, but I have to change it into that existential quantifier category. So how could I do that? Well, I could change it to the word some. I could change it to the phrase at least one. There exists at least one. Either of those would be options. So I think some is a little bit easier to write, so I'm going to go with some. But there's other options here. Some. Okay, so then we want to ask ourselves, if I keep the rest of the statement the same, will it actually negate it? Okay. All dogs go to heaven, and I change it to say some dogs go to heaven. Does that actually negate what's there? No. What does it do? It makes it weaker. It definitely makes it weaker, but it doesn't negate it, right? So what would I have to do as well as putting in the word some?
Some dogs don't.
I need to say some dogs don't. That's so sad, right? Some dogs don't go to heaven. Indeed. Okay, so the first thing to do when you're trying to change these statements is to identify the quantifier and which type it is and switch it, okay? And if you're looking at a drop-down list, like a multiple choice list, same thing. Eliminate the ones that still have universal quantifiers in it. It's an easy elimination. If it's got a universal quantifier, it is not your right answer. And then you're usually down to two options. That's kind of the way it goes. You're going to end up eliminating half of them. from what's left, you have to figure out what changed the statement to be the logical opposite statement. Okay? So this is what we would get here. All right, let's take a look at one that's in symbols next. Okay, so this one says x is greater than or equal to 5. The directions say, give a negation, do not use the slash symbol. So what does that mean? Well, it means that while it is true that I could write this down and put a slash through it, right? You know, like when we put not equals, that's not what they're looking for. It's not that it's not true, it's just not what they're looking for here. Are you with me? Okay, so this isn't what we want to do. We want to change it differently. So this is a no for the directions. What is the logical opposite of being x being greater than or equal to 5? Luke?
Would you put 5 on the other side? 5 is
Close.
less than a split x.
You'd have to change one more thing.
Would you turn the
Yeah, we need to take away the equals, strictly less than. So we could change it a couple of ways. So Luke suggested changing the sides. You could do that. Like this. You have to take away the equal sign though too. That's one option. Or you could leave them on the same side, and what could you change instead? You could flip the sign around. So instead of it saying greater than, it would say less than. And these two statements are exactly the same statement. This says 5 is bigger than x, and this one says x is smaller than 5. That's the same statement. And again, this is a really good example of one where they would just give you a drop-down menu to have to change each of the pieces. You've seen some of those, right? Where you have to fill in each of the different blanks. They don't give you a whole multiple choice options. Yeah. So they're probably going to actually force you to put the x in one of the places or the other and not give you a choice. Yep.
So it's going to give us the drop-down option, and we're going to have to choose. It could be.
That's what I think I remember seeing. Yes.
So either of those are going to work.
Either of those are going to work.
It's more likely than the other.
Correct. But I think they might force you to actually keep the x in a specific location. You might not have the flexibility to move the x around, is what I'm saying. So just to recognize that these are both right. All right, there are connectives that we have talked about, and I mentioned before the ones we're going to see the most. The connectives that we're going to see are going to be and, or, that didn't work right. Let's try that again. Or, and an if, then. And I'm going to put another one that's not really a connective, but it's got a symbol, and so it's a good place to put it. We're going to put the negation part and put the word not down here. It's not exactly in the box, but it fits in with the other lines, the other headers here. So there's symbols for all of these, okay? So the symbol for and is an upside down V. You can think of it as like a capital N, missing one of its like ending pieces. So it's kind of like an and. You can think of it as looking like an A with the middle line missing, a capital A, if that's helpful for and. You can also think of it, because it actually is for the same reason. Do you remember when we did intersections, and we did intersections and they were upside down? Just like the upside down U's? This is an upside down V for the same reason. Or is actually the V symbol. So or mimics back to our union symbol, where it was the U that was up, right side up, right? So if you were in my family or my husband's family or both, that's this or that's coming into play here. Same symbol, but with a V instead of a U. If then actually uses an arrow. And not uses a tilde. Okay, so on a keyboard, a tilde is in the top left-hand corner of your keyboard. If you haven't ever used it before, that's where you find it on your keyboard. You might be looking for it, okay? There's usually some boxes inside of my math lab too where you can select symbols, and the tilde might be in that box. These all have different types of, are different types of statements. The first one, the word and, is called a, get it written right, conjunction. It's called a conjunction. An or statement is called a disjunction. The one that's an arrow is called a conditional. And we've actually already talked about the one that's the not. It's called a negation. So what our next couple of examples are going to do is they're going to take either symbols and have us write out the words that go with them, or over here, words, and turn them into the symbols so they look like this. We're just transposing language, okay? So what does this tilde mean? Not, or the negation of a statement, right? It's the negation. So what does the statement piece say as it's given in the instructions?
Leah is a teenager.
Leah is a teenager. So what's the negation of Leah is a teenager? Leah is not a teenager, so that's what we're going to write down. We don't put the not at the beginning. I realize it's coming in front of the P, but we have to have our grammar structure so that it makes sense. So we will say Leah is not a teenager. Maybe she just turned 20. Or maybe she's 12 and she thinks she's a teenager because it doesn't have the word teen on the end, so it doesn't count. That's what we've told my children before, right? 12 is not a teenager. Maybe that's Leah. I don't know. All right, the next one is the upside down V here. What's that? And. So we're going to write and. Easy enough? All right. The last one, tilde Q. So this is the negation again. That tilde is showing up. What's Q? Tom is a lawyer. So what's the negation of that statement? Tom is not a lawyer. Tom is not a lawyer. Okay, is that all right? Changing those? Oh. So I have that still going on in my paper. It says Joe. Does it say Tom in your book or in your paper? And I'll just take it here. We'll make this say Tom. Maybe this time I'll remember when I get back to my office to fix it. No promises. I'll try. All right. Whoever the name is, let's pick the same guy that they've got on the list. Let's go with that. All right. All right, so we're going to go the other direction now. We have a statement given to us, and we're going to turn it back into those same symbols that we saw on the previous slide, and they're on here again as well. So this says, Leah is not a teenager. Okay, so the statement about Leah, is it P or Q in this one? It's P. And if it says she's not a teenager, what does that mean I need to do? I need the squiggly, the tilde in front of the P. Okay? So this is my first statement. Leah is not a teenager. It breaks it apart then with the word or. How do I do the or?
Upside down, so
The V, the right side up V actually, yeah. So it's a V, good. And then I have the statement, Joe is a lawyer. That one's just Q. Okay? So we intermix any of these symbols all into the same problem as we're working through them. Okay, the last thing that we're going to take a look at. It is going to harken back to something we've discussed before, but it's something you've discussed in high school and junior high as well. So it's actually talking about true and false statements. But some of the true and false statements are going to call upon prior knowledge that you have and you may not remember. So you may have to sort of think through some of them and be a little bit careful. This first one's one we've talked about in class. It's talking about the types of numbers. Irrational. It says all irrational numbers are real numbers. Okay, so what are irrational numbers? Do you remember from my picture that I drew back on section 1?
like
Pi is irrational. E is irrational. There was another type of number that showed up in this category.
Is it I?
Nope, it's not I. I are imaginary. Good guess. Somebody said something.
I said square root of 2.
There you go. That's the other ones. The radicals that are not easily simplified or not able to be simplified nicely, right? These are irrational numbers, okay? So we first got to make sure we're talking about the right thing, right? Are these also called real numbers? Yes, they are. And the picture that I drew you, if you wanted to go back to the section and look at it, was a big giant box, and everything in the big giant box was a real number, and we split it. Part were rational, part were irrational. So this is a true statement. Next one, whole numbers. It says each whole number is a positive number. Okay, so what are our whole numbers?
0.
1, 2.
Okay, these are all our whole numbers. Okay, So you have to think about what are the whole numbers before you can make a decision here. Are all of these, and the list continues, positive? Zero. Zero is not positive. Correct? It's not negative either. It's neutral. It does not have a sign. So all it takes for this statement to be false is one item not working. Because I've got this quantifier that says each, which means it has to be true for every single one. And it's simply not. So this statement is false. Okay? All right, that's the end of 3-1.